Hi all, and thanks for having me on Data Talk again. Cool runnings. So Power BI has always been the final layer of data in the data ecosystem. So we create data flows, we create data pipelines, and we transform data in those items, and we make that data available as the most refined and work layer to users. And this flow normally would stop there, and rarely will be the data from these semantic models be used for other purposes after that, other than analysis. So today I want to talk to you about Semantic Link. It's a feature that is available on Fabric and which will add a new layer of analysis to our semantic models via the notebook experience in Fabric. To introduce myself, my name is Rui Carvalho. I've been working with data for over 6 years, currently as a data and analytics engineer at Scope. It's a company located in Portugal, in Porto, and we build data solutions for clients around the world. I specialize in using Microsoft technologies to build ETL solutions for different sectors, such as data pipelines and data warehouses. I also write blogs on the Medium almost every week about data topics or about day-to-day challenges, not only technical things, but also at a professional level in data engineering. And in the last 1 year and a half, I've been working as a speaker, and I have taken part in multiple events, both online and in person, such as Power BI Summit, SQL Bits, and Data Toboggan for the first time. So what is this semantic link? So while we are talking about semantic link, we are talking about a feature that allows us to query semantic models through the data science model in Fabric using the notebook level experience, specifically using PySpark functions. So the main goal here is to use the gold layer that is the semantic model. We are talking about the most refined layer of an architecture, which is, like I said, the semantic models, and avoid redundant work between the multiple areas and the multiple teams. And in this way, we can use these already built semantic models for analysis, validation, and automation, and also for AI and machine learning models. So in this way, we have managed to create a complete data cycle, like you can see here. Since we began to work the data, we store the data that is built, that is extracted from files, from Parquet, CSVs, databases, whatever. We store that in the one lake, and after that we build the Power BI models, the semantic models, and which used to be the end at the Power BI. And now we can use that same data for purposes other than just reporting, completing this full cycle of analytics. So about the data structure on Semantic Link, we are talking here about the Fabric data frame. Okay, and the Semantic Link is based on a data structure, at least for the ones that are used to data frames, and these data structures will understand better this concept. But basically, Semantic Link is based on a data structure that is called Fabric data frame, which is basically a subclass of the pandas data frame. So it has all the features available in pandas, as well as a semantic information and lineage of the structures it stores, such as measures, tables, relationships, and dependencies related to that specific object that you store on the data structure. And all this information can then be used for all kinds of monitorization and validation of your semantic model artifacts. Okay, so basically, since you store anything, once you connect to the semantic model and you start to store things, store data from tables, data from a complete model in a data frame, you will have automatically access to all these features that are inherent in the semantic model, measures, tables, relationships, and you can use this for a lot of things in Semantic Link. Using Semantic Link in Fabric, how can you use this and what can you use this for. So basically, Semantic Link has a large library of functions and methods that you can use on your data set. From the simplest things like listing tables and measures from a specific data sets or for all of your data sets from your workspace or your tenants, read relationships and dependencies from the models and list that via functions, read tables, data into data frame, like I've said, read and run measures from your model or even DAX directly from your model in your using your Spark engine. And this is the what I consider the most interesting thing here is find possible relationship and dependency errors. So basically, we consider a relationship error to be when we have, for example, more records of relationship key values in the fact table than in the dimension, for example. And we can consider a time dependency error to be when there is an inconsistency of data in the same table. For example, having the same zip code corresponding to different cities in address table. Okay? Just a quick example. So this is some of the most straightforward things that you can do with semantic links, and you can do this to do a lot of things that I'm going to show you after. And I believe the semantic link, this will bring a participative role on semantic models for other types of users that they didn't have before. So, or at least have very few interaction with semantic models. And we can consider three personas here. I can talk about data scientists, data engineers, and Power BI developers. So each one of these personas, since they have access, a much deeper access to the semantic model data, they can do different things depending on what they need for their requests for the projects. So as a data scientist, I may want to use Python to interrogate the data on that semantic model and relationships of the semantic model without having to spend time recreating all the logic in pandas for exploratory data analysis. And I can use that to get some questions on the data, to create models, and so. And as a data engineer, for example, I want to be able, for example, to validate the data of a Power BI, a semantic model that someone has developed. So this way I can guarantee the quality of the dashboard. So imagine this process that a data engineer can create for data quality in a layer between development environment and production, for example. Very useful. And of course, as a Power BI developer, I can also leverage these semantic link functions to, for example, to be able to create documentation for my data sets in an instant way, easy way, using these functions to do it automatically and immediately once I create my semantic model. So there's a lot of things and that you can use these functions to leverage your work. Once I show you what the functions are in specific, the goal here is for you to imagine and think how can you use these functions to improve your work and make more automation on data validation and data quality on your semantic models. That's the goal. So basically, we give access to every different user, those three personas mainly. So this way we can create a great ecosystem, a great data ecosystem between these different roles. And of course, we are talking here about Python, okay, or PySpark. And this is why I believe this collaboration between these personas is also achieved, because the base language of Semantic Link is Python, which is already a very evolved language with numerous libraries for different things. So you can use the Semantic Link functions along with the Python functions to leverage this feature. It's one of the language of choices of data scientists, and of course, we are talking about a programming language with a lot of knowledge across, and of course, it will allow you, at least for this kind of work that you want to do with Semantic Link, it will allow you with a high level of automation of this process of data validation. So it's very, very, very cool to have that. So let's start and let's dive into my favorite Fabric environment, and I will show you some Semantic Link possibilities right here in my workspace. So here I am in my Fabric workspace. So I have my environment already created. I have lakehouse. I have a folder with some semantic models that I will use and consult with Semantic Link. And I have my PySpark notebooks where I have some Semantic Links notebooks where I'm going to show you some features. I believe I'm not going to be able, with the time I have, to go along all these five, but I will be as quickly as I can to get you into the most of the semantic link as possible. So I have the two of those five that I really want to show you today. In this basic notebook, basically, I will show you the basic features of semantic link. So basically, with the basics, you can do all the rest and try and start to build your automations on data validation. So this is a notebook in Fabric, okay, for the ones who don't know, to use and run the functions that I'm going to run now. You have to be linked to a lakehouse. So if you expand the tab on the left, you will find your lakehouses. If you don't have any lakehouse link, you can add one right here. Okay, so I'm gonna collapse this one, and the first thing that you need to do to start using Semantic Link is to install Semantic Link libraries. Until the Spark 3.3 version, you will need to run this pip install command for Semantic Link to install the Semantic Link libraries. But since the Spark 3.4, you don't need to do that anymore because Semantic Link is already available by default in the runtime when you're using Fabric. So basically, my version is 3.4. So it's okay. I don't need to run the pip install, but just take a note on that. So let's start very simple to run this first cell. So basically, one of the things that we need to import first is to import some Fabric methods that I have available in Semantic Link. So basically, I need to import the SemPy, that is basically the library of the Semantic Link, and I will import SemPy.fabric, and I can call it whatever I want. So I'm going to call it Fabric. And the first thing that I'm going to do is going to run the list datasets method to give me a list of the entire datasets in this workspace. Okay, and I'm going to store that in a Fabric data frame. So I'm going to run this cell, and in an instance, I will have my complete list of datasets in this workspace. Not all on there's a possibility to list the datasets on all your tenants, so all your workspaces. If I have time, I will show you. I can do that too. But basically, I have access now to the dataset name, dataset ID, create a timestamp, and the last update. So one thing that I'm going to do first is I'm going to pick one of these data sets. I'm going to work for now with these USA chips, and I'm going to start to, for example, if I want to read a table from these data sets. So one thing I can do here is to, at least for the first thing that I'm going to do is define this data set name as a variable. So I'm going to define a data set equal to USA chips, that is the data set name, and I'm going to use another method to list all the tables from this data set and output that tables list. So I'm going to run this cell, and I'm going to get listed all the tables from this data set. So we have a table named date, a shipment, a product, and a region. Okay, so if you add any description, you will have it here. If you can know which table is hidden or not, and so on. So one other thing that I can do is also list all the columns of your data set or from specific tables. In this case, I'm going to list columns from the data set, and basically what this will give me is a complete table in the data frame, in this case, with the table name, with the column name, data types, if it's hidden or not, formats, the source, if it's unique or not, if it's sorted by any column. So we have basically all the information on the columns from this data set. So very cool. We get this information directly from the semantic model so far. and save it in a data frame. So we can do with this whatever we want. And of course, like I said, I can read for a specific table. So if these kind of methods take multiple parameters, so I can get this data set as a parameter, and I can also get this the table name as a second parameter. So if we in this case, I am going to run a method called read table. So basically, we are going to read the data directly from that table, in this case, to a fabric data frame. Okay, so if I run this command, I will list the content of the table shipment that happens to be the fact table on this data set. So this is the content of my table. So what can I do with that? I can, of course, pick this data from the semantic model and work with this data for what is useful to me without going to the source of this data, replicate the transformations in my environment and do what I need to do. Instead, I can go directly to a semantic model already built, already validated, and use that information for the work I need to do. Okay, and I can also save if I want. I can also save this data as a table in my lake house. A fabric data frame has a different method to save a table on a lake house. For a common PySpark data frame, we would have a save as table, and we will choose as a specific lake house. In this case, we have this method. So we are going to save the shipment data frame. We're going to call this method to lakehouse table, and then we will call the name of the table that we want to save, and we will choose the mode that we want. It can be override, it can be append, whatsoever. In this case, we are going for override. I already have the table created here, so basically I will run and out, and this will save the content from my table that is on Semantic Link as a table on the lakehouse. This can be useful, or you can just work with the data in the data frames. Okay. So this, and of course, there we go. We have the complete scheme of the table, and you can start using this data directly for your tests, or other people that has access to to this one lake can also consume this data that you have created. Okay. So this is some things, some basic things that you can do with tables. So let's start to dive deeper on this. So let's talk about relationships. What can we do with relationships? So for each of these categories, I will need to import a few more libraries. So in this case, I will need to import some relationship libraries and related to things that I want to do with relationships, like plotting relationships, finding relationships, and list relationship violations that I will talk about next. But the first thing that I want to do, I'm going to use the same data set, USA chips, and I'm going to first, of course, import these libraries, these functions from the libraries, and I will use this method called list relationships from this dataset. So basically, this will give me a list of all the relationships available and created on the dataset. So what I have here, I have the relationship that I've created from the table from column from to the destination table. I have the multiplicity of the relationship, if it's active or not, if it's one directional or bidirectional, and so on. So I have all this useful information on my relationships. And I can also use, if I want to see this as a diagram, I can also use this method called plot relationship metadata, and I will basically pick this relationship variable that is basically the list of the relationships that I saved from my data set. I can use this relationship variable to basically create a diagram with those relationships. So if I run this step, I will get the diagram of the model that I have. Okay, very cool. So we get the factual table shipment, and I have my date dimension, product dimension, and vision dimension with the column that is used for this specific relationship. Okay. So now let's talk about the relationship violation. So this is a thing. This is where you really can use semantic link to leverage your data validation. So basically, what we want to do with relationship violation is, for example, I want to found um, between my tables, if I have, for example, in my facts table, if I have more product primary keys, more primary keys on my shipment table as I have in my product dimension. So this means that I will have product primary keys here. So I have products in my shipment that doesn't match anything in my dimension. So this is a relationship violation where from both sides, I don't have a full relationship between the values. So I will show you how you can detect it using semantic link. So one thing that we need to do first, we need to build a dictionary with all the tables that I have in my model. This will be very important because we will combine the tables with all the specifications on semantic attributes that that table might have. We will relate that with the relationships, and after that, I will plot and list the relationship violations. So first thing that I need to do, I need to create this tables dictionary, and basically I will do an iteration on my data set for every table, and I will list those tables name. Okay, and I will save that content from those tables in this as a dictionary. Basically, this is important because I need to save all the content from my tables to be able to validate the relationships from my notebook side. So I will need to go over the data to be able to see if there's some keys that doesn't match in any of those sides, even dimensions on fact tables. So in this case, I'll create a dictionary key with keys for those tables, the four tables from my model, and um, after that, what I can do is run this command list relationship violations, and I will pass as a parameter this table dictionary, and then I will pass as another parameter the relationships that already exist from the data set. So with that, I might have something to see. So as you can see here, these two lines represent two relationship violations that I found in this model. So this lists the specific relationship, with some specific attributes, so that I know with which relationship this talks about. And it has a message that says to me that, for example, I have 6 out of 5 of the 56 values in shipment dimension, the region PK, that are not in the shipment table, on the region table, sorry. And the same thing for product. I have 4 out of 203 values in shipment, product PK, primary key, that are not in the product dimension. So I cannot expand this message, but it's what it says. So I'm detecting values in my fact table that are for region and product that are not in the dimension. So this represents a problem that needs to be taken care of. And I can also do another thing with relationships. So I can use these functions to find the new relationship. So I'm going very fast on this one because I believe it's not very useful in the day-to-day basis because we usually build our models, we already create the relationships. So this can be interesting as an informative way. So you can have some automatic process that runs your semantic models and tells you, so there's a possible relationship here that you might want to see. But nevertheless, I will show you how you can do that. So basically, I have a model here just as an example that has no relationship created. Is basically the same model but without relationships that I'm going to save in this variable. I'm going to list the actual relationship with list relationship method, and I will plot the actual relationships of this this model. As you can see, it didn't found any relationship. That's good. That's what I want. So now I'm going to do the same thing. I'm going to create a dictionary of the tables. Same thing that we did above. And now what I'm going to do here is to run this method, find relationships, and I'm going to pass some parameters here. As you can see, there's a lot of parameters that you can use. You just need to check the documentation so you can find a complete list on the parameters that you can use. So basically, in the find relationship method, I will pass the tables dictionary that I want to search for these relationships. I will exclude, and I'm going to exclude the actual relationships. Okay, so imagine if this model has any relationship already created. I don't want that the find relationships finds these already created relationships, because this it will find them if they are created. So what I'm doing here is excluding the actual relationships of the model. I'm going to add this threshold, name similarity. Basically, the default is 0.8. I'm going to go for a 0.7, whatever. I'm just going to search for similarities on the name of the columns. That can be a relationship. And of course, coverage threshold that will search the coverage of the data between those two columns. That might be a relationship. Okay, so if the coverage is on this threshold, it might be detectable as a new relationship. So if I run this, I will have the three relationships that I already have created, but with this find relationship, it detected that this relationship can be created. Okay, so this have a lot of information on that. So the coverage percentage, the unique count from each of the tables. Okay, so this might be interesting for you to analyze. And let's go for another thing that you can do, and this is about dependencies. So basically, dependencies can be between two columns from the same table. Like I said in example in the presentation, we can have an address table, and the zip code can have multiple can have multiple cities. So this is a error in the dependency. So, and we can detect these dependencies and find dependencies violations, like we did in relationships. So let's import another method for dependencies. I will read. In this case, I will go back to the data set that we first read, the USA chips. In this case, I'm going to read a table. This is my region table. Okay, that has the countries, the states, zip codes, and cities. And okay, and now I'm going to run this find dependencies command. So let's on the region table. In this case, I'm not going to pass the parameter data set. I'm going to run this method over the region data frame that I've created above. So this will give. Okay, not this one. I want to show you the dependencies. All right. Okay. So this is the dependencies that I have in this table. So basically, the region PK as a dependent the city, the zip code, and the state, and each of the zip code, the city, and the state as the country as dependent data. Okay, I can plot this metadata for dependencies, and you can see this in a graphical way. So if we want to start to find dependency violations, we need to pick two columns, for example, from this table, and so this can go for and search for a relationship violation. Of course, if you want to make this automatic, you are not going to do this for every column of every table. You are going to pick specific columns from specific tables that make sense to evaluate the dependencies. So in this case, in this region table, I'm going to pick the zip code. That is something that doesn't change between states and doesn't change between cities. So I'm going to evaluate if there's some dependency violations there. So I'm going to run this plot dependency violations on the region, the region table, in this case a data frame, and I'm going to search on the zip code between the state column. Let's see what we got. So as you can see, we found two relationship two dependencies violations actually. So in the zip code, the first one, we got two different values on state for a single of this single specific zip code. So we for this zip code we have Washington State and Indiana. We have another zip code with two different states, so Alabama and Missouri. So as you can see, this is something that cannot happen. That doesn't make sense to happen in the data. So this can alert us for us to take a look of our data, because probably it needs some correction and or something is wrong in the source data. Okay, we can do this in a few more tables. So with zip code and city, we have the same thing. In this case, you are seeing different values for a single zip code. But imagine that we have Washington and right this way, but we have another value with Washington with some using caps lock for every letter. This engine will assume that as a different value. So basically, anything that is different in something, it will be reported as a dependency violation. Okay, so this is very interesting also for your automations and data quality validations. And of course, I can list if I don't want to see this in a diagram view, I can just list this as a table and save it as a table. Okay. Going for the last step on these basic things that you can do on measures. So basically, I can also list measures from my data set. And in this case, I'm going to run this for a different data set that is called SL flights. So basically, we have these measures. We got the measure name, we got the measure expression. So the formats, if measure is hidden or not. So we have some information on the measures that I have in a specific data set. What can I do? I can evaluate these measures and run these measures on my engine. So basically with this evaluate measure method, I can run and calling the dataset flights, that is the dataset that I'm using. I can call the measure that I want to run. And for example, I can group by these by specific columns from my datasets. Okay, if I run this, I will get the value as a summarization of this measure over airline and country airline. I can also use filters in this evaluate, and in this case, I will filter for the airport of origin to be Alaska, and again, I can have the result of my measure directly in my notebook from using the content from my dataset. I can also run some SQL, or first I can run DAX directly in the notebook. I will show you after a case where I build a measure, but in this case, if I load this extension of functions on the SempI functions, this will load me some extensions. And then if I can call this DAX, and I will apply DAX on a specific data set, in this case, the LCL flights, I can run a query, for example, like this on my data set. I can search in this DM view for example, active relationships. And I can also see the result on this from an DMV. I can query SQL on my Power BI. For that, I will need to run this configuration, okay, to get the catalog. And then I can just type SQL and run the SQL query over my Power BI, and I can select the data set, and I can select, for example, the measure folder. And in this case, I will apply the measure that I want to do in this query. For example, I want to do the sum of airlines grouped by the origin airport, and this will work good as well. So this is the basic stuff that I want to bring to you. So let's talk about something funnier. So the second part of the demo that I will going to show is about Great Expectations. For the one who doesn't know Great Expectations, they have some methods to do some data validation over your data assets like databases, your tables, flat files like CSVs, and data frames. So this way you can use these already built data validation and data quality methods to guarantee high quality data, to do data documentation, data quality reports, and you can and logging and alerting on some specific violations that you may encounter on your data. So basically, what happened before is Great Expectations used to validate the data quality across the steps of a Medallion architecture. And now basically Fabric, Semantic Link opens the door for Great Expectation to connect and use these methods to apply data quality validation over the semantic models. Okay, let's see this in Fabric. I am again in my workspace, in this time in another notebook, fully with Great Expectation methods for you to see how you can leverage these methods on the semantic link. So we need to install an additional libraries for Great Expectations like these ones. There's a few more depending on the methods that you are using, but for the methods that I'm going to show you today, these are enough. So I need to install these libraries as long as Semantic Link, but you'll need to if you have the Spark 3.4. But you need to run this first command. And after that, I will need to import any additional libraries and methods for Great Expectations. So this is, of course, a methods that I will need to use for these specific configurations and expectations that I'm going to set. So the first thing that I'm going to do again is to search for my list of data sets. This time I will find a different data set. Let me see if I have it here. So this time I will choose the retail analysis data set. Okay. And the first thing that I need to do in the GX or Great Expectation context is to define a context that basically will have access to all the configurations and methods of Great Expectations. So all the methods, all the configuration, I will store in this context. So I got my context created. The next thing that I'm going to define is a data source. So a data source that I want to validate. And for that, I will open the context, open the sources, and add a Fabric Power BI. I will give it a name. This time will be a retail analysis data source as a name. And the data set I will use is the retail analysis. So I'm going to create this data source to be validated. And now I will need to specify some data assets. That is basically a subset of data that I will use to validate. Okay, so there are three things that I want to validate in this notebook. I want to validate the Power BI table data, I want to validate the Power BI measure, and I want to validate the custom DAX query. So in this first table asset creation, basically what I need to add, I will create an asset for a table. And this is very simple. I just need to add to my data source. I need to add a Power BI table asset. This is the name that I'm going to give it, the store asset. Store is the name of the table I want to add as an asset to be validated. And of course, I will set the table equals store that basically I'm going to use it as a data asset. So I create a Power BI table asset. Now I'm going to create a measure asset, and this is basically using add Power BI measure asset on your data source. In this case, again, this is the name of my asset, total units asset, and I want to this to save my measure total units grouped by fiscal year and fiscal month. This is another thing, another asset to be validated. And finally, I want to also validate a Power BI DAX asset. So it's directly validating DAX that is executed in this semantic model. So this will be called the total units year over year asset, and I will pass the DAX string right here to be validated. And after creating the assets, I need to create the expectations. So what do I expect from the data that I have here? So remember that every validation that will be going on here is going to be using the semantic link to connect directly to the data from the semantic link models using semantic link. In this case, let's add what I'm calling the constraints of your assets. So the first thing that we need to do is adding suits. So basically, suits are the subsets of data expectations that you want to use to validate your data assets. So in this case, I'm going to create the first suit store, and basically I will add this suit. What that's what is called in GX. I will have this suit uh, on my context. I will create it with this name, and then in the suit store, I will add an expectation. In this case, I will add two expectations. The first one, I will validate the postal code column from the store table up there. And basically, I will use this method that will basically see if it's a valid zip code or not. Okay. And I will add another expectation. And this is one of that will basically count the table rows, and I want them to be the value to be in a between 80 and 200 as a minimum and a max value. Okay, so this is the true expectations that I want to validate here. And after that, I will just add to my context. I will add the expectation suit that we already created, and this expectation suit is the suit store. I will run this, and I will run the same thing. So let's move on for the next suit that we need to do is on the measure this time. So again, I will add another suit to be using this retail measure suit. The expectation that I'm going to create is the column values to be between again, but in this case I want the measure, that is the total units, to be in a minimum value of 50,000. Okay, and I will add this suit to my context. And finally, I will create another expectation, this time on the DAX query that I want to run. The expectation will be, and again, an interval on the measure value to be between 0.8 and 1.5. So again, I will create this expectation suit and add it to the context. So we are increasing our context so that we have everything we need to validate our data set or semantic model. Let's go for the validation. So basically, we created everything we need. We need to create now a checkpoint config that basically will have all the validations that I want to do. It's basically a subset of validations that I want to do on my data source. So in this case, this is the validations. We have three validations that we want to run. The suit has all the expectations that we want to check, and the batch request as the data source name and the data asset name that we want to validate. So each expectation suit is associated for each of the data asset that it relates to. Okay, so I will run this just to have my checkpoint config ready to go. And then I can just click on and use checkpoint.run. So I can have results, and I have basically these validations running over my semantic model, and this will produce a result based on the data quality validation that these methods did over my semantic model. So it's executed in 10 seconds. I can now display the results. It is basically displaying me a JSON with all the output. And I will transform, I have a command to transform this JSON right in the table, in the data frame. And as you can see, this is all the batches of validations that we have run. We have run two validations on the store asset, one validation on the total units asset, and one validation on the DAX query asset. And basically, as you can see here, we got success true, and we got a false. So basically, we see that one of the validations failed. That was the one on the DAX query validation. And this means that he found some unexpected counts that were three values. And I can see listed here in this partial unexpected list the values that did fall from the interval that started in 0.8. Basically, I can now pick the DAX query and run it directly on the retail analysis dataset and check if I see where these values fell out. So as you can see, I found the three values that fell out of the interval, starting at 0.8, going for 1.5. We fell out on January, in April, and in July. So we found some validation that we might need some attention. So there was a lot of things to show. I know that I was going very fast here, but I believe if you go back in this session, if it was going to be recorded and watch it carefully, we will go and slow and learn more how you can use these methods. There's a lot of methods that you can do that I didn't talk about it today, so you can search on them on the documentation, and you will see that you can do a lot more with Semantic Link. There's also a lot of people using semantic links and already building scripts for you to use on your semantic models to increase your automations and data validation. So I will challenge you for you to search on that. So thank you very much for watching my session. I really appreciate for you to be here today. Unfortunately, I couldn't be in presence, and I need to do it in virtual. But please, if you have any question, scan this QR code. This will go directly to my social links. Send me a message on LinkedIn with your question. Go for it. And of course, there's a link for feedback. I really appreciate feedback on this session. I'm trying to improve it, and I believe your feedback will be amazing for that. So that's it. Thank you very much, and I hope you enjoy the rest of the event. Bye.